let's say problem 22 on page 122. A equals P plus PRT, and we're asked to solve for T. This is another very important concept. It's called solving formulas. Solving formulas for a particular variable. I see several variables here. I see A, uppercase A, I see P, I see R, and I see T. There are 4 variables. Why would they pick T? I don't know. But we are asked to solve for T. I have to assume that A is a number. So in my head, I'll say, I don't care. It's a number. P, I don't care. It's a number. R, I don't care. It's a number. I'm only solving for T. So imagine that those are numbers and the only variable is T. What will you do first?
Subtract P from both sides.
Of course. That's what I want. I want that P to go away. So I have A minus P equals PRT. Awesome. Like we just did. That's exactly what we did here. We took 18x, moved it to the other side, it became negative. We took negative 351, it was negative, we moved it to the other side, it became positive. Same thing here. I took P from your right to your left, it changed its sign. Good. Final step. I need to solve for T. What am I trying to get rid of? And that's where my little notebook with my concepts. What am I trying to get rid of? I'm trying to get rid of something in front of T. How is that called? The coefficient of T. Good. How do I get rid of the coefficient of T?
Divide both sides.
By?
PR.
Exactly, by the coefficient of T. You can write this if you want. PR, PR. Yes, remember we can simplify only. What is the term? That's another thing that we need to put in our notebook. What did we say? We can only simplify what? And we can never simplify this. We can only simplify in a proportion. I can cross multiply. Awesome. But we can only simplify
Like terms?
if I combine like terms. But simplify. Very good. Let me write this down. So combine like terms. Yes, I can combine like terms. But I can simplify only. It's the other one. Never terms. But,
Factors.
thank you. I can simplify only factors. When I say factors, it means multiplication. If multiplication is combined with something else, those are not factors anymore. So, I simplify this factor and this factor. Or if you want to say P and P, one factor, and R, one factor. So the simplified form, or the answer is A minus P over PR. Question. I want to simplify this P with this P. Acceptable or not?
No.
Yeah, you're correct. So I cannot simplify this with this. Why? That's fine. They are factors. P and R are factors. Not because of that.
Is it because it's negative?
No, not because. You have something, but I want to use a word. Because P at the top is not A, but A. Is not a.
Factor by the term.
Exactly. Exactly. P is a term. That's why I cannot simplify it. P here is a factor, but P here is a term. because it's connected by subtraction to something else. So the simplified form is A minus P over PR, and this is it. No one can further simplify this. Done. I want to look at a percent or a mixture problem or both. Okay, before we start working on our own. Yes, problem 19 on page 134. Find the original price of a pair of shoes. If the sale price is $78 after a 25% discount, I know you may say sometimes, okay, why do I need this? I'm doing such and such and such and such. True. Unfortunately, every piece of information is so valuable these days. This is very useful. So I take the shoes and I go to pay. And I pay $78. Put my shoes in the car and I go. My question is, how much was it really the price, the original price? Okay. Because I got a 25% discount on the original price and I ended up getting the shoes for $78. So what was the original price? Now, this is another very important concept that you have to put in your list of concepts or important information. Here it is. If I say I have in my pocket 25%, you should look at me and say, it means nothing. 25% of what? If I say I have 25% of $1, then I have 25 cents. But if I say to you I have 25% of what Bill Gates is worth, that's 25% of 90 billion. So by saying I have 25%, you should say meaningless, meaningless. Explain. Put continue 25% of. So a 25% was a discount on what? On the original price. Awesome. So 25% of, this is the key word here, of the original price. Do we know the original price?
No.
Give it a name, please.
X.
Awesome. So when I say now, this is a very important piece. What operation do I translate the keyword of into? Awesome. This is always multiplication. So when I say 25% of blah is 0.25 times x. So this changes into 0.25 times x. And this is the discount. So now I have to come up with an equation. I ended up paying 78. What is on the other side? Is the original price subtract what?
0.25.
Nope. 0.25 has no meaning. We can never talk about 0.25.
0.25.
We can never talk about 0.25 or 25%. As I mentioned before, nothing. It means nothing. So from x, I must subtract the discount, not 0.25.
78.
So from x, I subtract the discount. What is the discount? It's not 0.25. Is I just wrote it here. Can anyone read this for us?
Discount.
And what it equals to?
The discount number is 6. What is it?
Oh, 0.25 times that.
Awesome.
Oh.
That's what I want.
Gee.
So from the original price, I subtract the discount. I don't subtract 0.25. This is extremely important to understand. Remember, 0.25 means nothing. If I say I have 25% in my pocket, you'll say nothing. Doesn't
Why
mean
is
it.
it x minus negative 0.25x?
Okay, one more time. From the original price, we have to subtract the discount. The discount is 25% of the original price. When I say of the original price, I have to use multiplication. So 0.25% of x is the discount, is the quantity that is subtracted from the original price. Is that clear? You cannot subtract apples from peaches, right? So 25% is applied to x. Because if it's not applied to x, then we'll have to apply it to Bill Gates' fortune. It has to be applied to x. So from the original price, I subtract 25% of the original price to get 78. Are you with me? Yes?
Yes.
Perfect. I have to combine like terms now. From a whole x, from 1, I subtract 0.25x.
Can you make that 1?
It's there. Oh, absolutely. Because when I say to you x, I mean 1x. Otherwise, I would have said anything else. Good. So from 1, I subtract 0.25. What do I get?
0.75x.
0.75x equals 78. Final step. What am I doing now? What am I trying to get rid of? And what is it called?
Coefficient.
Coefficient of x is how much now? 0.75. I'm trying to get rid of that. I'm using the multiplicative inverse, or I can say I divide by 0.75, or I can say I multiplied by 1 over 0.75. Is the same thing. Because it's the multiplicative inverse of 0.75 over 1. So then x equals 104. I trust you. It's $104. Okay, now I want to check my work. So if I want to check my work, I will say 104 minus what? 0.25 of or times 104 should equal 78. Okay, I have my calculator already set up, so I can do this. 104 minus 104 multiplied by the discount. And if the answer is not 78, then I know something is wrong. Any questions on this? Any questions? Okay, so let's look at another problem like 30 on page 135. 30 on 135, it says the number 56.25 is 45% of what number? $56.25 is 45% of what number? So, say it again.
So the number is unknown. It's x.
Yes, we want to call the number x. That's fine. Okay, can anyone give us a setup, an equation that I can solve to get this x?
What did you get? 56.25 equals
Exactly. This is the key word. Very good.
0.45 times x.
That's it. Awesome. And that's the other key word. Exactly. So is gets always translated by the equal symbol. Of, in this case, in most cases, I shouldn't say all of them, depend, I have to see the problem. I would say of gets replaced by multiplication. What do I do now? Because we know how to solve equations. I would do what to both sides?
Divide by 0.45.
Yes, 0.45 is called what for x?
The coefficient.
Very good, the coefficient of x. Awesome. So when you divide it, I'm hoping you divide it for me so I don't waste your time. How much is it?
125.
How will I check my work? If I have any doubts, I multiply 125 by
0.05.
and get that. Good. So let's look at a mixture problem. Let's look at a mixture problem. 48. I need about 15 more minutes and then we'll start working on problems on our own. How much water? How much water? I'm taking some notes when I read the problem so I don't have to go back to the book, right? Should be added to 30 gallons of a solution that is 70% antifreeze to get a mixture that is 60% antifreeze. Okay. So let's read the problem one more time and then talk about it. How much water should be added to a 30-gallon of a solution that is 70% antifreeze to get a mixture that is 60% antifreeze? Every time I get a problem like a mixture problem like this one is with concentration and number of gallons or ounces, so on and so forth, my first thought is to create 3 bins. So this is the water. I'm adding it to solution. And here I know I have 30 gallons. And I have the 70% concentration. And the result is another solution. And what I know about this is that the concentration is 60%. So I envision 3 containers. A container with water, I don't know how much. A container with a solution that has 30 gallons, concentration 70%. And an third empty container. So here I have no clue how many gallons. What is the concentration of water, of antifreeze in water? I hope 0, right? Right? Good. So in the first container, I have some gallons of water. I don't know how much. In the second container, I have 30 gallons, concentration 70%. What does that mean? From the 30 gallons, 70% of them are pure antifreeze, and 30% of them are water. That's what 70% means, right? Remember, 70% means nothing. So I have to say out of the 30 gallons, 0.7 times 30 is 21. 21 gallons are pure antifreeze, and 9 of them are water. And they're mixed. And I have the solution of 30 gallons, right? Are you with me? So now I take these two containers and empty them out in the third one that initially had nothing in it. So I took this and I took this and I emptied them here. I mix. I have 60% concentration. Solution 60%. How many gallons?
How did you say that again?
Yes. In the first container, I have X gallons of water.
Mhm.
In the second container, I have 30 gallons, concentration 70%. 21 of those gallons are pure antifreeze and 9 water, so kind of mixed. I take these two containers, I empty them out in the third container, and I mix. How many gallons I have now? I know the concentration is lower because I added water.
Yeah.
So how many gallons I have now?
Would be a variable,
Yes, what is it?
X.
No. I have X in here.
30X.
I'm not multiplying. I cannot multiply gallons by gallons. I get gallons squared.
0.30 plus X.
Not yet, no. I'm only talking about gallons now. I'm not talking about concentration. One more time. In this container, I have X gallons of water. In this container, I have 30 gallons of mixture. I take these two in the third one that is empty.
It would be 30 plus X.
Awesome. I had the original 30 and I added X. Right? Good. Perfect. Now I need an equation. The equation can be either in pure antifreeze or water. I only need one equation. So if we use pure antifreeze, gallons, number of gallons of pure antifreeze plus, coming from here, number of gallons of pure antifreeze coming from here equals the total number of gallons of pure antifreeze. How many gallons of pure antifreeze come from the very first container?
Nothing.
Nothing. Plus, how many gallons of pure antifreeze are in the second container that I will put in the third?
70%.
Of,
30.
yes, remember 70% means nothing. So how do I write that?
You say it was 21?
Yes, 0.70 of,
Times 30.
exactly, awesome, equals the number of gallons of pure antifreeze in the resulting container.
60.
I can never use 60. It has to be,
Is it X?
I have to put the concentration first. What is it?
0.70.
What is the concentration in the third container?
30.
What is the concentration in the third container?
X was 30.
That's the number of gallons.
Oh.
What is the concentration
0.76.
in the third container? So this piece is this. This piece is this. Now we reached this stage.
Oh. Is it 0.6X?
0.6? No, X is not the number of gallons in the third container. What is the number of gallons in the third container? We have to be consistent. So maybe I should have written 0 times X, 0.00 times X, plus 0.7 times 30 equals, we just have to mimic what we just did for the last.
Plus 30.
Exactly. So now this is 0.60 of the number of gallons I have because I mixed it. It's solution now. That's why it decreased from 70% to 60% because I added something that had no antifreeze. It did not add on to the antifreeze. Awesome. Any questions here? Any questions? Okay, so this is 0. We already know that 30 times 0.7 is 21. What do I do on the other side? It's called, the concept is called what? What am I trying to do now? The blah, blah, blah law.
Distributive
The
property.
distributive property or distributive law. Okay. So 0.6 x plus what?
0.6. Wait.
Multiplied by 30. Good.
Oh, got it.
Good. So now, as we did so many times today, what will I do next?
You moved the one with the variable on the.
Oh, you can. You can, but since I only have one term with a variable, I will move 18. So 21 subtract 18, I get. So this is 0.6. I know the coefficient of x is 0.6. I will do what to both sides to get what I'm looking for.
You divide both sides.
Good. So I divide both sides. 3 divided by 0.6, and I get 5. 5 what? Now I have no choice but write the measurement unit. It's part of the problem. So please make a note somewhere. I
Gallons?
must write exactly. Gallons of what?
Water.
Yes. So if to 30 gallons, 70% concentration in antifreeze, we add 5 gallons of water, we will get exactly how many gallons? 35 gallons of concentration what?
Solution.
Of solution with concentration of what? 60%. If we have 70% concentration, 30 gallons, and we add 5 of water, the resulting solution has lower concentration, of course, more gallons. Okay, so let's look at a motion problem. Motion.
I do have one question about
Yes,
the last
please.
one, though.
Yes, please.
So the question is how much water should be added, but
Yes.
we calculated pure antifreeze. Why?
Very good, because I have to be consistent. Very good question. Let's write the equation in pure water now. Very good. So I cannot say solution plus solution equals solution because they have different concentrations. So one possibility is the amount of pure antifreeze brought by the first one, which is 0, plus the amount of pure antifreeze brought by into the resulting solution by the second one equals the number of gallons of pure antifreeze resulting in the third solution, right? So if you have 3 apples and I give you 2, then you have 5 apples, correct? So I cannot consider this one in water and this one in antifreeze and this one in something else. So I had to be consistent. Now let's write the same equation. An equation for the same problem, this time in the number of gallons of pure water.
Okay.
Awesome question. Number of gallons of pure water. I shouldn't say pure because you know what I mean, water, plus number of gallons of water equals number of gallons of water. Awesome. Okay. So let's come back. Very good question. Okay. How many gallons of water? How many gallons of water we have in the first container?
X.
Awesome. Plus, how many gallons of water we have in the second container? We had 21 of antifreeze. How many we have of water? For sure, right? Which is 0.3 times 30. The concentration at 70% is in antifreeze. So the rest must be water. Yes, please.
So how I calculated that was 70 over 100 times 30, and I still got 21.
Yes, the 70% because it's 0.7. 70 over 100 is 0.7. Good. Now, equals. In the number of gallons x plus 30, how much is pure water or water?
That'd be 40%.
Exactly. 0.4
Yeah,
multiplied by?
X plus 30.
Exactly. So now this is another consistent equation. You understand number of gallons of water from the first container plus the number of gallons of water from the second container must equal the number of gallons in the resulting container. Because the initial third container was empty. So I'm bringing these two. How many gallons of pure water am I bringing? So I have to think in terms of either pure antifreeze all the way or water all the way.
Mhm.
I cannot mix and match because I'm not going to get the solution. Now the answer must be 5. So let's go ahead and do it. So this is indeed x plus 9 equals 0.4 x plus 12. I distributed 0.4 to x and yes.
So just in case we have a different question that doesn't involve water or anything like that, do we have to write what are the, how do I put it?
If it's a mixture problem, it's one or the other. It has to have two
So-
different things, minimum.
Okay.
Yeah.
So I wanted to find out if it's the x plus solution equals solution. That's the same way we work it out.
No, it's the number of gallons of pure antifreeze plus the number of gallons of pure antifreeze equals the number of gallons of pure antifreeze. Like, for example, money plus money equals money. People plus people equals people.
Okay.
Yeah. Good. So I'm bringing 0.4 and I'm bringing 9. When I bring 0.4, it becomes negative. From 1 whole, I subtract 0.4. When I subtract 0.4 from 1, what do I get?
0.6.
0.6x, and it's positive. When I subtract 9 from 12, what do I get?
3.
Perfect. And the final answer must be 3 divided by 0.6, which has no choice but be what? 5. Still the same measurement unit, gallons of water. Must be added. Is it clear now, Chris?
Yeah.
So the equations have to be consistent, because if you say number of gallons of water plus number of gallons of antifreeze,
So it didn't matter whether or not I did antifreeze or water. It was
no,
gonna
but it has to be
the same thing.
consistent.
Right. Okay.
As long as you are consistent, it doesn't matter.
Okay.
You decide. Okay, I want to look at a word problem on page 144. I said a motion problem, so yeah, what about 25? Alan and Dave leave from the same point driving in opposite directions. So one goes this way, and the other one goes this way. So this is Alan, and this is Dave. Alan is driving at 55 miles per hour, and Dave at 65 miles per hour. Alan has a 1 hour head start. Make myself a note. He started 1 hour earlier. How long will they be able to how long will they be able to talk on their car phones if the phones have a 250-mile range? So I go west at 55 miles an hour. You go east at 65 miles an hour. But I start an hour earlier. So I leave at 8 o'clock in the morning. You leave at 9 in the morning. So I already have covered some distance, right, in 1 hour, right? So I leave at 8, you leave at 9. I go west at 55 miles an hour. You go east at 65 miles an hour. Question is how long it takes till we can no longer talk. So we can talk between 8 and some time. At 8 a.m. I leave, but we have sometime, maybe an hour, maybe 2, maybe 3, maybe 4, I don't know. And we can still talk. And then the conversation stops because we assume that our cell phones have only a range of 250 miles. That's it. Any suggestions? First of all, we will call this uniform motion, which is not entirely correct. I can't get at 55 miles an hour unless I start at 0. By uniform motion, we mean constant speed. Not possible in real life. But assuming this is possible, the distance equals rate times time if no acceleration or deceleration is involved. So assuming I have a mechanism in which I start at 55 miles an hour. So D stands for distance, R for rate, T for time. Good. So then, knowing that, and this is the distance covered by you, and this is the distance covered by me, and I do start 1 hour earlier. Let's see what we can come up with. Can anyone give us an expression for my distance covered? What is my rate?
65.
Minus 55. Multiplied, what is the time? Unknown.
Yeah.
Time is unknown, but on this is because I start early. I'm an early riser. I start at 8 and you start at 9. So I have an additional hour that I already used. And you're using only T. I'm using T plus 1 because I started an hour early. You're using only T. So then what is my distance? 55 multiplied by? Perfect. Plus, what is your distance?
65.
65 is not a distance.
250.
This is your 65 miles an hour. And this is your,
Just be T.
yes. So what is your distance now?
T.
T cannot be a distance. R cannot be a distance.
It's
The product has to be the distance.
It would be 65 times T.
Correct. What will this equal to? I'm going this way, 55 times.
250.
Exactly. We're going in opposite directions. I cover the distance 55 times T plus 1. You, the other direction, 55, cover the distance 65 times T. And then we'll know exactly how long we have to talk.
So you move the formula rate times time equal to distance.
So this is the distance covered by me, distance D1, and this is the distance covered by you, D2. D1 plus D2 equals 250. Is that okay? Perfect. So what do we do now? And what is the word we're using for what we are going to do now? We're going,
Distribute.
very good. 55t plus 55 plus 65t equals 250. We should always start by combining like terms. Like in this case, I have two terms with t. So 55 plus 65 is 120. T plus 55 equals 250. Now what do I do?
Subtract 55.
Of course, I move 55 to the other side. And I get, what is it, 195?
Mhm.
And then t, how do I get t? By dividing by its coefficient. And what did we get? 195 divided by 120, I got 1.625 hours. Don't forget the measurement unit. So we can change that if you want into minutes and so on and so forth. This is good enough. An hour, yes?
Can you write out the coefficient, how you divide from 195?
You mean from here?
Yeah.
You're welcome. Very good. Last thing, and then we have about 20 minutes to work on problems. Solving inequalities. So let's look at a simple one. 42 on page 154. Like 6, 2 minus x greater than or equal to 12. This is a linear inequality. How do I know it's linear? It doesn't have x in the denominator. The power is 1. There are no variables that are multiplied. The same concept with the linear equations. So this is solving linear inequalities. Last topic for chapter 2. Remember the two keywords? Simplify, factor, simplify, factor. We don't know factor a lot till chapter 5 and 6, but simplify. I will simplify. I will divide both sides by 6. Why? Because I noticed that this and this are divisible by 6. You can say, I don't want to do that. I want to distribute. Fine. Distribute. That's fine. You're going to get the same answer. So if I divide both sides by 6, again, if you want to see it, it's this. Please write 1 so you don't make a mistake. So the new inequality is this. Again, the same idea like before. I need to get rid of what, and what do I do with it? Of course, I need 2 to go away. Subtract 2 from both sides. 2 minus 2 is 0. So what do I do next? What is the coefficient? Yes?
I have a question.
Sure.
Why didn't you distribute the property?
You mean 6? Okay, let's distribute. So if I distribute, I have 12 minus 6x greater than or equal to 12. I subtract 12 from both sides. I have negative 6x greater than 0. Same thing. What we're going to do is the same thing. As I said, if you'd like to distribute, distribute. Now, what is the coefficient of x? Perfect. So I have two options when it comes to -1 and -1 only. I can say I multiply both sides by -1, or I divide both sides by -1. So -1 times -1 is?
1.
So the left-hand side is x. 0 times -1 is?
0.
Perfect. But now I have to think. I multiply both sides of an inequality by a negative number. This is another thing for our little concept thing. What do I need to do when I multiply both sides of an inequality by a negative number? And only when I multiply or divide by a negative number. the inequality symbol gets flipped. It was this, now it's this. And finally, in interval notation, the interval notation is very important. X less than or equal to 0. 0 is in the middle, negative infinity, infinity. Which direction am I going into? Am I going to the left or am I going to the right? Where are numbers less than 0? To the left of 0 or to the right of 0? Right, correct. This is the interval with a bracket. Why with a bracket? Because the inequality has the equal symbol. So in interval notation, we like to say x is found in the interval negative infinity to 0. Yes? There is no negative or positive 0. It's the same thing. Any questions?
So the flipping of the sign, that only
Yes, let me explain.
That only applies to greater than and less than, right?
It does. Yes, only to inequalities.
Right.
Yes.
Okay.
So let me
Obviously you
explain.
can't flip it.
Let me explain why. Is 2 less than or equal to 10? Is it true? Is 2 less than 10?
No.
Yes.
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 Would you like to have 2 or 10?
10.
Because 10 is bigger than 2, correct. But it depends on what. Let's say dollars. But let's suppose that I decided to multiply both sides by negative 2. This becomes negative 4, and this becomes negative 40. Is negative 4 still less than negative 40?
No, it's greater
No.
than.
So that's the reason why we have to switch the inequality symbol when we divide both sides by a negative number or multiply both sides by a negative number. So this is our note. Flip the inequality, only the inequality symbol when multiply or divide both sides, when multiplying or dividing both sides of an inequality by a negative number. Only when you multiply or divide by a negative number. Okay, one last one here. Let's say 56, and then I'll choose a few problems for you. And you can say, wait a minute, this is not an inequality. This is 2 inequalities. Yes, I agree. It's called compound. 2 inequalities put together. What 2 inequalities? This one and this one. Okay, you want to solve for x? What would you recommend would be the first step done to all 3 sides? 1, 2, 3. What should I do to all 3 sides to get closer to solving for x?
You add 6.
Of course. Add 6 here, add 6 here, add 6 here. Awesome. I need to get rid of this. That's my first step, first target. So the left-hand side, I have 6 plus 4. What do I write?
Okay.
Thank you. What do I write in the middle?
5x.
Awesome. What do I write on the right?
25.
Awesome. What will be the final step? Because I want to get rid of the, and how is it called? The coefficient of
X.
x. Indeed. So I will divide all 3 sides by 5. When I divide 10 by 5, what do I get?
2.
When I divide 5 by 5, what do I get?
1.
Right, because that's the multiplicative inverse. 5 and 1 over 5 are reciprocals of each other. And the right-hand side is 5. In interval notation, I will write x is in the interval. I don't have to graph it. How do I read this? And this is another very important concept. How do I read this? If I say to you, I have in my pocket anywhere between $2 and $5, how will you represent that mathematically?
It's basically saying x is between 2 and 5, isn't
That's
it?
exactly it. That's exactly it. With brackets because of the equal symbols, bracket. If there is no equal symbol, we use parentheses. Okay, so let's take a look at, tell me what you would like. You would like solving formulas, word problems, inequalities. Please choose.
Equality.
Okay, so we want to start with going backwards. Very good. So let's look at 46 on 154. So that's -5 quantity 1 minus x plus x less than or equal to negative quantity 6 minus 2x plus 6. I'm putting in the attendance, that's why I was logged out. Kathleen is here, Melissa is here. Cassius, thank you. Kirsten. Shelby. Whitney's here. Keontae. Ruby's here. Corey. Yes. Melissa is here. Howdy's here. Nicole. Nicole is here. Yes, of course. And Chris. Okay, how are we doing? We're doing this problem. The one you got. Yeah.
Okay.
How are we doing? So you distributed perfectly. Perfect. You change the sign. Perfect. You change the sign. So you combine that terms. Perfect. This one's here. Okay. You move this here. Okay. You have to subtract first. I would subtract and keep the variable on the left hand side and profile the other.
Okay.
Careful on that.
That's perfect.
That's perfect. One more step. It's not done. Change 2x into 12x. Always over this. Okay. How are we doing? We have to distribute. We have to distribute first. How are we doing? You distributed to 1, but you did not distribute to x. Careful. Careful with the distributive law. How are we doing? So this is 6x. This is not x. So this is x, but this is not. Something is wrong here. It's 1 minus x. So not both of them have x. Yes. This is not minus. Negative 5 times negative x. How are we doing, Chris?
Kind of stuck.
We don't divide before we bring x on the same side. I can have terms on both sides and then divide. So x has to be only on one side.
Oh, yeah.
Okay, so can anyone walk us through this? Step 1, please.
It's -5
Yes?
plus 5x.
Good. Do you all agree with this left-hand side? -5 plus 5x plus x. Yes?
Yes.
Okay, the right-hand side.
-6 plus 2x plus 6.
Good. These two go away because I combined like terms. I did not simplify. These are terms. I combined like terms. Now I have to combine like terms on the left. What do I have? Yes. That's another concept for you. Please, I'm going to write it down in your little notebook, please, of concepts. Always keep the expressions in descending order of the powers of the variable. That is a good habit to acquire. Note, keep expressions, algebraic expressions of course, in descending order of the powers of the variable. It's not a mistake to write -5 plus 6x. It's fine. I recommend getting into the habit, like I'm suggesting the habit of moving terms and not having to write plus, plus, minus, minus, plus, plus, minus, minus. I recommend this as well. Okay, so then the left-hand side is 6x minus 5. Here's what I would do. It's not the only way. I accept other methods, of course. I would do this. That's another habit of mine that I highly recommend. Try. Sometimes it's not worth it. But most of the time, I recommend keep the variable on the left, on your left-hand side. That's another note. Keep the variable, if possible, okay, and so on and so forth, on the left of the equal sum symbol or the inequality symbol. Okay, so by moving 2x to the left, I get a 4x. By moving -5 to the right, I get a 5. And then I have to, this is not enough. I'm not done, right? I have to do what to both sides? Divide both sides by? Very good. Not by 4x. We only divide by the coefficient of x. Maybe you said that, maybe you didn't. I just want to emphasize. Forgive me. This is very important. We only divide, we never divide by x. We only divide by the coefficient of x. So that is 5/4. I didn't have to switch the symbol of the inequality because I didn't divide by a negative number. So now in interval notation, this is 0. I don't care for units here. This is my 5/4. Which direction am I going to? To the left or to the right of 5/4?
You're going to the right.
I cannot go to the right because this would have been to the right. So x is less than or equal to 5/4.
Oh, right. Okay.
So it's this. But if you're saying I'm going to the right from here, yes, I completely agree. So in interval notation, x is found in the interval negative infinity 5/4 with a bracket. Infinities always have parentheses. Let's try at least set up a 33. Yes, I know we only have 5 minutes left. Now, for next time, and I will email everyone, please try to finish everything. So next time, at least 1 hour, we use for reviewing for the test. Okay? 2 cars leave Pecos, Texas at the same time and both travel east. So they both travel east. This is car 1 and this is car 2. And this is 33, and I forgot to write the page, 144. The first car speed is 70 miles an hour. And the second car speed is 58. When will the cars be 30 miles apart? So again, here are the cars. They are going in the same direction. And they do this. Stop. They are 30 miles apart. That's all I care about. They start here at the same time. 30 miles apart. Okay? So they both start here. This is the distance covered by the first one. That is faster. And this is the distance covered by the second one. So this one is the 58 mile per hour. And the green one is the 70 mile per hour. Very similar to the 250. Slightly different. So please tell me what to do, what to write. So the green one covers the distance AB. The red one covers the distance AC. Till they are 30 miles apart. What will you tell me to write? Of course, T is T. Because they start at the same time. There is no delay. One does not have a head start. The other one is not delayed, and so on and so forth. So, can anyone dictate anything?
70 TB on one side of the equation?
70 times T, okay, equals, awesome.
Would the other side be 58 times T
Awesome,
plus 30?
awesome. So this equals this plus this. So notice how I presented a little graph that signifies what I'm trying to find and what is the situation in the problem. I showed that the green is covering this, and this is the red, and the distance is 30 between the two of them. Awesome. So then 70t, if you want, minus 58, t equals 30. How much is 78 minus 58? And finally, what do I do to both sides to get t?
Divide by the coefficient.
Divide by the coefficient of t, which will give us 30 divided by 12. I'll simplify by 6, and I get 2, so it's 5/2. So t equals 2.5 without writing the measurement unit. That is, the solution is not complete. What is the measurement unit?
How is it 2.5?
5 divided by 2. Or you divide with your calculator 30 by 12, and you'll get 2.5.
Oh, so you multiply it?
I have to eliminate this coefficient. In order to eliminate the coefficient, I have to use the multiplicative inverse. I multiply by 1 over 12.
Yeah, I know the answer is 5/2. Why are you saying 2?
I simplified 30 by 6, and I got 5 like we did last time. And I did the same thing to the denominator. I divided